Well, that quantity of energy right there is the heat of fusion. And our symbol for that is delta A. And then let's use that heat of vaporization as a ratio, kilojoules per mole. First of all, let me just show you a heating curve. I'm sure you've seen this for water. And we're going to start with a very low temperature. Here's my temperature, and then as we go to the right, we're adding energy. So I'm going to start off with a very cold solid, and then we're going to get to this part where the temperature doesn't change and we're putting in a bunch of energy. Well, that quantity of energy right there is the heat of fusion. And our symbol for that is delta H FUS, heat of fusion. And so that quantity, you just drop those lines down and measure that amount of energy. Then we're just going to continue up this curve. We heat the liquid. So now we're all liquid, and we're going to transition into a vapor. And so what is this called as we go across here? Well, we're vaporizing. And so this amount of energy, this quantity right there, is the heat of vaporization. That's the energy it takes to vaporize that liquid into a gas. Okay, so that's where these values come from. You can make a heating curve for any substance, but someone has done that for you and given you these values, and you will find these values in tables. It is per 1 mole of a substance, so you'll find those. Let me show you a problem or two of how to use those. All right, so our question is, how much heat is required to melt 2,500 grams of ice? And we are at that melting point. So remember, fusion is going back and forth between solid and liquid. Vaporization is liquid and gas. So I want to use the heat of fusion. All right, so let's start with my given. It's grams. I have grams of ice. I need to get to moles, and so 1 mole of ice is 18.02 grams. And then let me use that heat of fusion as a ratio, right? Because it's 6 kilojoules per every 1 mole of ice. And so when we multiply, grams cancel, moles cancel, and we're left with kilojoules. And that would take 830 kilojoules to melt. And doesn't that make sense that it's per mole? The more ice you have, the more heat it takes to melt it. So let's look at another one. This time, how much heat must be removed to condense? Condensation is going from a gas to a liquid, so I'm going to use that. All right. Now, when I condense something, I have to not put the energy in. I want to remove the energy, slow those particles down. Okay, so we start again with our grams of water. And let's go ahead and convert that to moles. The molar mass has not changed. Okay, and then let's use that heat of vaporization as a ratio, kilojoules per mole. And then, of course, when we multiply, the units will cancel, moles, and we're left with 56 kilojoules has to be removed to condense. That's how you use heat of fusion and vaporization.